Welcome to the muscular system. We're going to be reviewing the upper extremity model for Bio 210. Unfortunately, our atlas does not have a really good supraspinatus muscle picture, so I've taken one off the internet. And so we're looking here, what's being pointed out is the supraspinatus, and it is above the spine of scapula, and it is responsible for about the first 15 degrees of arm or shoulder abduction, and then the deltoid kicks in to help get it past the first 15 degrees all the way up to about 90 degrees, and then that last 90 to 120 degrees is supraspinatus activating more freely then. So this is actually a figure from the textbook that we use for the course, and you can see, of course, the supraspinatus being pointed out as well on this location right here. Okay. Now here's another picture of the upper extremity model. This one is not in your book, but it has been rotated a little bit and kind of dipped down so that you can see the supraspinatus peeking out. What has happened is the trapezius muscle has been cut away at this location. That's an overlying muscle that also helps with shoulder abduction past the 90-degree mark. The infraspinatus is another rotator cuff muscle, and it's basically used to adduct or adduct the arm, and it can also laterally rotate. Lateral rotation would be equal to external rotation. And so you can see the infraspinatus muscle being pointed out here. On the torso model, the infraspinatus muscle is also seen. It's not my favorite view to test on because it can be a little confusing for students, but either picture is still showing the infraspinatus, so it is fair game. So earlier we had seen the infraspinatus muscle. I'm going to use black so that we can see the infraspinatus muscle here. All of this area here is the infraspinatus muscle, and what's being pointed out is the teres minor muscle. It's this little area right through here that's peeking out underneath. The teres minor is also part of the rotator cuff. It is used for adduction and lateral rotation as well. So on the anterior aspect of the scapula, we have the subscapularis muscle, and this muscle is kind of fan-shaped, and it goes from this border to over here. All of this is the subscapularis muscle. It too is part of the rotator cuff muscle. It is useful for medial rotation of the arm, meaning internal rotation of the arm. So if you notice where it attaches to the humerus, kind of on the anterior aspect, when this muscle contracts, it's going to rotate that humerus internally. So altogether, we had the supraspinatus, the infraspinatus, the teres minor, and the subscapularis muscles, which compose the rotator cuff muscles, and the acronym for that is SITS, S-I-T-S. So here we're looking at the deltoid muscle, and its primary movement can be abduction of the shoulder, it can be flexion of the shoulder, and it can also be extension of the shoulder. So it's depending on which section of the deltoid is being activated. And you can see the anterior aspect of the deltoid here. So let's say these fibers here were getting activated. That would assist the arm in flexion or shoulder flexion. If the lateral ones out here were being activated, it would assist in abduction or abduction. And just looking at the upper extremity model again, we can see the deltoid muscle, this triangular shaped muscle outlined here, which inserts onto the deltoid tuberosity of the humerus. Now continuing into the brachium or arm, we see the biceps brachii muscle. I've taken the picture from your book and rotated it a little bit so we can have a little bit bigger blow up of the picture. And so again, you see the biceps brachii muscle. It's very important that you put as part of your answer the term brachii, because that determines what area of the body that we're talking about. So looking at the lateral view, some might call it the posterior view, depending on if you're looking at anatomical position. We see the biceps brachii from the outside as well. The next muscle we're looking at is the triceps brachii muscle. It works in opposition to the biceps brachii. The biceps brachii muscle is responsible for elbow flexion, and so the triceps brachii muscle is responsible for elbow extension. And another look from the lateral aspect or the posterior aspect, we see the triceps brachii muscle again. Now there's a muscle that actually rides just beneath the biceps brachii that is called the brachialis muscle. On this particular view, it looks like it's riding next to it, but the brachialis muscle is a primary mover or agonist for elbow flexion. So the biceps brachii would actually be what we would consider a synergist muscle. It helps with the elbow flexion, and the triceps muscle, triceps brachii muscle, would be considered an antagonist. It is actually opposing elbow flexion. Another muscle that we'll see, which is anterior, or you might say medial based off of this picture, is the coracobrachialis muscle. It is also responsible for arm flexion. And just revisiting one more time that subscapularis muscle. And one more time from this view, looking at the teres major. Again, the subscapularis muscle is from here and over, and the teres major is going to be this little section over here. So now we're going to be moving into the muscles of the forearm or the antebrachium. And the first muscle we're looking at is the brachioradialis. It's named from where it comes from, the brachium, down to the radius. So it's the brachioradialis muscle, named for origin and insertion. And this muscle is responsible for elbow flexion as well. If you would think about holding a can of Coke or a mug of beer or a glass of wine in your hand, and then you're moving it towards your mouth, that motion, that activity with that thumb in the upright position is responsible, is done by the brachioradialis muscle. Now looking at the lateral view of the upper extremity model, you can see the area where the brachioradialis muscle is sectioned off so that you can see it from this view as well. So now we're looking at the anterior compartment of the forearm or antebrachium, and we see the pronator teres muscle. This muscle is responsible for the action known as pronation. If your elbow was bent to 90 degrees and your hand was palm up, like you're cupping a cup of soup, and you were to rotate your palm down towards the ground, that would be pronation. And the muscle that assists or actually does this activity is the pronator teres muscle. So now we're looking at the extensor carpi radialis longus muscle. We also have an extensor carpi radialis brevis, which we'll see on the next slide. The extensor carpi radialis longus muscle is responsible for extension of the wrist and abduction of the hand, and it's going to originate on the supracondylar ridge of the humerus and then cross down on the radial side to the carpals of the wrist on the radial side of the hand. So previously we had seen the extensor carpi radialis longus muscle. Now we're moving to the one right next to it, and you can see the little outline here of the muscle that's peeking out underneath. This is the extensor carpi radialis brevis muscle. This too is responsible for wrist extension and abduction of the hand, but it originates on the lateral epicondyle of the humerus. So sometimes people who play a lot of tennis will get what's called lateral epicondylitis, and this is one of the areas of the forearm, the musculature that becomes tight and spastic and causes increased tension on the tendon, which is causing that inflammation. So now we're looking at the extensor digitorum muscle, and this muscle is responsible for extension of the wrist as well as the metacarpal phalangeal joints of the second through the fifth fingers, as well as the pip and dip joints, so the proximal interphalangeal joints and the distal interphalangeal joints. So this definitely helps us with our finger extension. And then just next to the extensor digitorum muscle, we have the extensor digiti minimi muscle, and the extensor digiti minimi will help extend the finger of the fifth finger of your hand. You can kind of think of that as when your little pinky finger sticks out when you're drinking a cup of tea. That's the extensor digiti minimi muscle that's doing that type of activity. So just next to the extensor digiti minimi muscle is going to be the extensor carpi ulnaris muscle, which we can see again stemming from that lateral epicondylar region and going down to the ulnar side of the wrist. And it is responsible for wrist extension and as well as abduction of the hand. Now this particular view is not in your lab manual. I just took the upper extremity model and kind of flipped it around a little bit so we're seeing it from the side, the same type of angle that you would kind of get a karate chop from. And so over here I'm pointing out the extensor carpi ulnaris muscle. I want you to see that even though it kind of looks like it's drifting over to the anterior aspect, where it originates is from the lateral epicondyle, which we can see is kind of in this area right here. And it still ends up on the ulnar side of the wrist on the posterior aspect. So that's going to give us still that ability to do extension. So now when we go back to the anterior aspect of the forearm, you can see a little bit of the flexor carpi ulnaris muscle as it's peeking out. Again, the flexor muscles are going to come off of or near the medial epicondyle, which we see in this location. The extensor muscles are going to be closer to the lateral epicondyle. So it originates from the medial epicondyle, and the flexor carpi ulnaris muscle is responsible for flexion of the wrist and adduction. So we've turned that model on its side again for the second part of our karate chop. And while previously we had seen the extensor carpi ulnaris pointed out right now with the little arrow here, now we see that the flexor carpi ulnaris muscle is just a little bit more anterior. The big takeaway is that it's still stemming from this medial epicondylar region, and it's going to the ulnar side of the wrist, but now it's on the anterior aspect. So all of your flexor muscles are on the anterior aspect of the forearm, and the extensor muscles are on the posterior aspect of the forearm. You can see being pointed out the flexor carpi radialis muscle. Again, this is for wrist flexion, and when we have an issue with the flexor carpi radialis muscle and not the flexor carpi ulnaris muscle, you might see that there's still some wrist flexion available, but it might be a little bit problematic, not as strong and equal. The flexor carpi radialis is also responsible for abduction of the hand. Another wrist flexor that we have is going to be the palmaris longus muscle. And it too comes from that medial epicondyle, which we see over here. And if you follow its tendon, it goes down and it goes across. It actually goes across the palm to spread out a little bit. That's our palmaris longus muscle. So the last muscle we're going to look at is called the anconeus muscle, and it is on the posterior aspect of the forearm, and it crosses over to the humerus, and you will see that it is responsible for extension of the forearm, or we could say elbow extension at this point. And again, a slightly different angle, but we can see the anconeus pointed out to in this region here. So when it contracts, the elbow or forearm will extend or straighten out. So this concludes the muscular system, the upper extremity model for Bio 210.